Hello and welcome to today's session. In this session, we would be discussing about advanced Kubernetes and Kubernetes cluster. So advanced networking, what all things are the components of a network, how do we expose our application outside the network, all those things we would be dealing today. So let's see today's agenda. So we would be discussing about Docker networking because we need to have a fair amount of idea about container networking so that we can understand why exactly a container networking interface is needed and how does the networking on a Kubernetes level happen. Because we are running containers wrapped up with the pods, we need to understand exactly how the container networking happens, and then we would map that to our Kubernetes networking. We would learn about container networking interface. There are different types of container networking interface which we would see, and then we would understand why it is needed and all. We will talk about Kubernetes networking. How do we expose applications within a network, outside the network, different ways of exposing the applications that we would be dealing with. We would be learning the different types of service to expose the application. And then at the end, we would be learning about Ingress and Ingress controller. So there are different types of ways in which we can access our application. So services and Ingress controller are different types of doing it. We would see when we would do that as well. So let's start with Docker networking. So today it is more in terms of pictorial representation in diagrams and all. And as and when needed, we would switch back to our terminal, see how exactly it is being depicted in the cluster. So when we are talking about Docker networking, how it is, we have a server, let it be a virtual server or a physical server. For example, in case of DigitalOcean, think it as a droplet. A droplet would have an Ethernet interface. So this is the ETH of your virtual machine, which is the droplet, and it has an IP address. You install Docker on that, and that machine is called as a Docker host. So what exactly is a Docker host? When you have a Docker software running on the virtual machine, it is called as a Docker host, or on a physical server, it would be called as a Docker host. As soon as you install Docker, you would have a default set of networking in getting created in that, and in that you would have three network types getting created. One would be the none, one would be host, and the last one is of our interest, which is the bridge type of network, and that network is also called as Docker zero network. When we are spinning up containers, these containers are actually getting launched on these Docker bridge. So Docker bridge obviously would have an IP address, and when you spin up a container, it would get an IP address which would be on this bridge. So what would happen? It's an internal IP address. You can't expose your container outside. If someone from outside wants to reach inside to your container, the application which is running inside the container, you can't, because the IP address of your container would be an internal IP address. So let's see, I'm trying to spin three different types of container. It would create a vEth pair on this particular Docker bridge, and if someone tries to reach this particular container from outside, how would that be? So I would reach the ETH0 of the Docker host, and from there the packet would be transmitted to Docker 0 bridge, and from there it would go to the respective container. And this way we would be landing to each of the containers. But just imagine if three containers are working, then three of the containers would not get tied up to the same port number on the host. Rather, for example, think if packet is coming on host port 80, that means on this Ethernet interface on port number 80, if it comes, it would go to container orange. If it is coming on port number 81, it would be routed to container blue, and if it is reaching on port number 82, it is going to container green. So this way you can tie up one of the ports on the host to a port inside a container, and that IP address to mapping would be happening from the outside IP address, which is the external IP of your host, mapping to your internal IP address of your container. So this way, this IP address mapping happens and we reach something which, when a container is running, we reach it from the outside world. But what happens, there is some limitations with Docker networking. When these containers are running on the same machine, they can talk to each other. Orange container understands blue container is present, green is present. It can just find out or do a DNS resolution with its name itself and can reach each other with the IP address. They are on the same bridge. But if we have two hosts like this, like if I have two hosts and each of the hosts have a different set of containers running, this is node 1 and the other one is the node 2. I have Docker installed on both the nodes. I have a set of containers running on node 1 and set of containers running on node 2. What would happen? Can my orange container on node 1 reach the orange container on node 2? As such, it can't reach without any internal connectivity between node 1 and node 2, right? So that connectivity with normal Docker doesn't come. So this connection is not known to Docker. That is the reason when Docker came into the market, they could only spin up containers on the Docker level on a single host. And when multi-host thing came into picture, they didn't had any technology around that, and Kubernetes came into play and multiple hosts forming a cluster and all that came into picture. Later Docker came its own solution called as Docker Swarm, but that didn't become that popular in market and people adapted Kubernetes very well, and that's the reason we are using Kubernetes, right? So it's pretty famous. So this internetworking between two hosts which have the intelligence of running containers, that is stitched by Kubernetes. So let's see how do we do that. So to do this, we need something to interconnect two types of bridges, right? One bridge on one machine has to talk to the other bridge on the other machine. And this can only happen when you have a thing like a router type of thing or an overlay type of network, which can connect one network to the other network. So network one to network two connection can happen if we have an overlay type of network in between. Then the packets can transmit from one network to the other. So let's see what we need for this. So Kubernetes has a solution called as Container Network Interface. It's a CNCF project, and it interfaces. It's an interface between the container runtime and the network implementation. What happens? Normally, you create files in the JSON format. So there are a lot of third-party plugins which give you this. You need not have to implement your complete networking on the Kubernetes. Like below, you can see there are so many options available. You can have Weave, you can have Calico, you can have Flannel, you can have VLAN. A lot of solutions are there in the market, but what exactly they do, we need to understand. One host to other host connectivity, they can stitch up. And just imagine that whenever a container is coming up, you got to have an IP address of that. That IP address has to be mapped to the IP address so that it can open a port, the IP table entries, all those things are automated. So what happens whenever there is a container spin up, the container network runtime creates a container, a namespace is created, network is attached to it. So obviously when a container is getting created, it will get an IP address if it is launching in a network, right? So that mapping to that network to the container attachment happens. And whenever you're deleting, the deletion of the IP address, the deletion of all the entries, all those things will be handled by the CNI, whatever interface you are taking. And that is what exactly the CNI, like for example, if you're using Weave would be doing all these functionality. You're using Calico would be doing all these functionalities. So it would orchestrate the complete network setup, starting from assigning an IP address to deletion of an IP address to mapping of an IP address and all that. It would completely orchestrate. So when we are creating a cluster in the beginning itself, because it's a managed Kubernetes cluster, you just mentioned that how many nodes you need in the cluster in the node pool. internally, when the cluster bring up has happened, it has already stitched up the networking using the CNI, and inter-node communication and node to master communication, everything is already been set up. So now when we are spinning up pod, or we spinned up deployment, stateful set last time, everything got an IP address. Everything was already automated because our network interface is already in place. So not to go more in deep of CNI, rather understand that it is an interface between the container runtime like Docker and the actual network implementation which has happened, so that it can orchestrate the complete network setup. Whenever a container is coming up, starting from the IP address allocation to the port allocation to mapping of the port and all, everything is handled by the CNI interface. So let's understand how exactly this happens. So we had a host 1, which was running Docker host, and the host 2. So this is our worker node 1 and worker node 2. We would also have kubelet running in case it is a Kubernetes cluster node, right? So think this as a Kubernetes worker node. We have worker node 1 on the left, worker node 2 on the right. And when you have to do a interconnection or talking of a pod 1 on the orange side of node 1 to pod 1 of uh, node 2, they can talk to each other via this LAN configuration. So what would happen? They can identify each other on the same cluster just because their IP addresses are from the same interface. They are getting IP addresses in the same range. If you spin up multiple containers, you would see they would get an IP address from the same range because the network remains the same. So same way, like for example, I have a network of 198.69.1.0. I would have, if I spin a container, it would have .1, .2, .3, like that IP addresses would be assigned, right? So here also it would happen the same. You have a range of IP address, containers will be IP addresses in that same range. So this is how the Kubernetes networking happens, but our containers or the pods are not accessible outside unless and until we define few things. And what is that exactly? How do we actually expose our applications within our cluster or outside the cluster is important. So when we are talking about pods and containers, remember that pods and containers don't have a static IP address. They have a dynamic IP address. And on reboot, these IP addresses will not remain constant. They will go for a reboot, then their IP addresses would change. So this IP addresses changing becomes a big problem. Like I have a as Nginx and a backend called as MySQL. If my MySQL keeps going up and down, my Nginx pod can't get in connection with the MySQL pod, right? It doesn't understand because the IP address keeps changing. What will I enter on my WP config file? I don't have an IP address to enter because the IP address is a dynamic IP address. So we get a new component into our cluster, which is called as service. So service is like a static entry. It would sit and monitor a type of pod. Just imagine that Nginx service will have an Nginx pod monitoring, and a MySQL service will sit and monitor a MySQL pod. Why I'm saying this? Because whenever your Nginx pod is up and running, and if it goes down, you don't have anyone to see whether the IP addresses has changed and what is the new IP address. Someone has to really sit and monitor what exactly is the IP address, right? So we create a new component called as service. Service is like a component which helps us reach the particular pod. And there are different types of services which can be created in our cluster. So let me take you to the cluster. So I am running this Nginx pod at this point in time. What is the IP address? How do I see? I can do -o wide and I can spin up, I can check the details. This is the IP address of the pod. If you see, the IP addresses are in a particular range for all these pods, right? 10.242. O dot, and then these numbers are coming up, right? So this IP address is an internal IP address. I can't reach my Nginx port from my outside world, because this IP address is not resolvable from outside world. So how can I be able to reach this particular resource from outside? Then I would have to create a component which can help us reach this particular pod. So in case of containers, go back to the first picture in which I mentioned that the containers are mapped to the Docker bridge and the packet comes to the node and then gets transmitted to the container. Same way here also we will have to create a mapping. So this pod is running on this particular node, right? 667KK node. So on this node, if the packet comes, how will the packet get routed to this Nginx pod is a question for us. So we would create a service kind called as service and expose this pod to the outside world. I think I had created the service. Let me check. I'll just delete the service and recreate it and show you the different types of services. Okay, so how can you create a service? You can create a service by exposing a component. Like, for example, here I want to create a service for a pod, right? So I would say expose a pod for a service. So kubectl expose pod. Which pod I want to expose? Nginx pod I want to expose. And when I want to expose this pod, I want to expose it where? Within the cluster or outside the cluster is the question. Like for example, Nginx type of applications I can expose outside the cluster, but MySQL type of application I can expose inside the cluster, right? So you have to decide how would be the connectivity to this particular application. So here I'm exposing it within the cluster for time being. So you would say type. For within the cluster, the type is called as cluster IP. And you would give a port number over here. I will come back to this port number. And you're exposing it like that. So I'll come back to the port number in a second. kubectl get service. This service is created. Now, if you describe the service, let us describe the service and see what exactly it means. This service of Nginx pod says that I am a service which sits and monitors whom? I sit and monitor. My selector is Nginx pod. If you go and see the description of the pod, it is labeled as run equals to Nginx pod. So it is monitoring Nginx pod, and here if you see the endpoint of the pod is mentioned over here. For a particular service, the target is the pod. When the packet comes to the service would forward the packet to the pod. And anytime any communication happens to the pod, it will happen via a service. So think of service to pod as a one-to-one mapping for now. Why I'm saying for now, because Nginx pod will have its own Nginx service, MySQL pod will have its own MySQL service, Cassandra pod will have its own Cassandra service, because I can't have a common service to sit and monitor every pod going up and down, right? So what I'm doing, I'm creating one component for each of the pods which are running, and I am making sure that there is one component monitoring that particular pod. So here Nginx service is sitting and just monitoring an Nginx pod. If I have to create a MySQL service and I want my packets to be properly communicated to MySQL pod, I'll create a MySQL service for that. Unless and until I create the service, the components can't talk to each other. So here, few things which I mentioned, the port and the target port, how it is on the cluster. This is the IP address of the service. So someone who tries to communicate, I'm just writing it over here. The packet would actually come here, and this packet would get transmitted to this particular port number. That means when you are saying in your WordPress or your Nginx, packet is actually coming to your service, and service then forwards the packet to the pod. Think of a deployment instead of a pod. If you create a deployment, let me create a deployment and show you. kubectl run command we can quickly use, and I would say Nginx dep and image is Nginx, and I will write replicas. Why I'm trying to show replicas, I'll tell you. So Nginx deployment is created. Let me check. Deployment is created. Yes, deployment is created. Let us see whether the pods are up and running. Okay, it's one is another creating state. Rest you are running. I'm running Nginx deployment pods. These pods are one set of pods, and I don't have connectivity to reach to them, right? So what I would do, I would create a service to reach to them, because now if I delete this pod will have a different IP address. So -o wide, I would even show you that. So here the pod is having .15, .23, and .241. Let me delete one of the pods and show you the IP address keeps changing. So let us delete a pod of Nginx deployment pod. You have deleted this. Let's quickly do white. And if you see, it is terminating, another is creating. And quickly, as soon as it creates, it will have an IP address associated to it. Yep. So here it had an IP address of 215, 23, and 241. So now it has got an IP address of 79. So what would happen if one of the pod went up and down? Your IP address changed, and you no more know at which IP address it is available, right? So what you would do, you would create a service. Service is not a process that it can be killed. Container is like a process which can be deleted, which can be killed, right? But service is like an entry. Think it like as an entry which can't be deleted. So you would expose this deployment. Last time I had created a pod, so I did expose pod. Now you say expose deployment, and name of the deployment can be given. I think I had given the name as Nginx dep, and I would say the type again. I'm again just exposing it to, you can either give equal to or you can give a space, and you are giving the port number. This is the service port number. Service is also getting an IP. So IP to port combination, it would receive the packet. And target port is, for a service, the target endpoint is a pod, right? So the target port at which Nginx is expecting to receive packet has to be mentioned over here, which is 80. So let's do this. It is exposed. So let's get the service list now, and let's describe the service. What would happen when I created a pod and had a service and described it? I would describe both the things for you at one go, and I'll show you. So I'll describe the Nginx pod service. It would have one endpoint, sorry. I'll just do a copy paste again. So let me pick this. Okay, describe of this, and again describe of the deployment service. Just type in. So if you see here, this is the output of the pod. Here the endpoint was only one. I had only one pod of Nginx, so my Nginx service pod was just monitoring one pod because it had this label for only one of the pods. My deployment service is sitting and monitoring 3 of them because the deployment has 3 pods with the same label. So service does 2 things. It is like a static IP address for the pods to reach, and it keeps monitoring the pod's IP address. It does a health check at the backend and finds which pods are up and running. When it is changing its IP address and coming back, it's coming back with the same label. So it has the selector defined. So that label selector matching happens, and it populates its endpoint over here. So here it is trying to monitor 3 of them. So what exactly it's doing? Just one step back and think of, like for example, everyone understands virtual machines and load balancers, right? When you have several virtual machines serving the same website, what do? You fit a load balancer in front. People reach the load balancer because your IP address of your virtual machines can change, but your load balancer's IP address is fixed. You fix a static IP address for your load balancer, right? And your load balancer keeps a health check of your virtual machines and does a load balancing. Exactly the same is happening over here. You have a service which is serving as a load balancer, as a health check, and as a starting point or the entry point for your packet for your pods which are serving as Nginx. So application which was running inside a droplet, the Nginx, that is actually running inside a pod, and you have a service in the front which will do load balancing across these 3 entries, and which will also sit and monitor these 3 entries. In case it is like, I'll go ahead and delete one of the pods and show you again. So I'll delete a pod, and I'll show you that the IP address of the service gets updated. Okay, so let's describe the service. Last time it was sitting and monitoring 23, 241, and 79. Now you see 186, 241, and 79. As soon as your container or the pod went down and came up with a different IP address, label selector matching happened, and service started monitoring the new pod, and it attached the new pod to its endpoint list, and it would load balance across these 3 now. Hope this point is clear. So this is the part of service. Service helps us, gives us a static way of reaching the Nginx pods at the behind or any other type of pod as well. And it would do load balancing if it has multiple replicas of it running at any point in time. So this is the functionality of service. Let's go back to our slides. So what happens normally for name resolution and all, Kubernetes provides our kube DNS service for this. And every time a service is created, the DNS service registers the IP address and all so that it can reach. So service IP address is static. Unless and until you go and delete the service, nothing can happen to the service. It's like an entry over there. There are different types of services. So let's see what all types of services are there. There is cluster IP, which I created. With this, it is only accessible inside the cluster. It is not accessible outside the cluster. I'll do a tweak over here. Let me go to my cluster. I have changed the password of the droplet node, which is working as the worker node over here, and let me open the console. I'm just doing a display of, I want to take my password and come back. Give me a second. Okay, so this is my console of my droplet. So here, if I do curl to that IP address that should be reachable, my cluster's IP address. So what was the IP address of my service? This is my service IP address. So if I do curl over here, you can see welcome to Nginx. Why I went inside the worker node? Because I am issuing the commands from my personal laptop, and that is just having kubectl command line interface installed and has the details of my Kubernetes cluster. It is not part of the cluster. When I'm saying inside the Kubernetes cluster, the cluster IP address is accessible, I should be either on the worker node so that I can reach the IP address, right? So if you see here, I do a curl from here, I will not be able to reach this IP address because this IP address is an internal IP address, which is the IP address of your service at this point of time. So I would not be able to curl to this, but if I'm going to worker node, I'm able to curl. That means anyone within the cluster wants to access that Nginx. Now also the web page is accessible to them. So let's see how do we change the IP addresses from a cluster to a node level and then on a load balancer level as well. So cluster IP address type of service is the one which is internally accessible. And then we can do a node port type of it, load balancer and an Ingress controller. We would be dealing with each of them in more detail. So let's go to the next one, which is the node port type of it. So in node port, what happens? You have a cluster and this is the node on the cluster. These are the pods which are running. So when I depict one single node as a cluster, just imagine that this is a worker node running in the cluster and I have a deployment with 3 set of replica pods in it. I create a service for it and I want to expose it outside the world. Till now, I was able to reach within the cluster, but I want to reach outside the cluster as well now. So what I would do a node port mapping. How we talked in terms of Docker, on the Docker host on a port number, I would map it, same way I would do. So I would say on this node, if this packet is coming on this particular port number, it should come to this service and service anyways know which pod to monitor and do a load balancing, right? So this stitch up would happen. So when a node port is created and user tries to access that node port, it would reach the service and service can guide us to this particular pods. So this is how the node port type of thing works. Let's try and convert this type of service, which is cluster IP, to a node port now. So before to that, I will do a kubectl get service to show you the difference in the output. You just have a cluster IP, which is the IP address of your service, and you don't have an external IP address. You don't have a port number, nothing is there. It just says that the service receives packet at this IP address at this port number, and service has the endpoint list. So service is receiving the packet at 10.245, 202.161:80 and sending it to either of these like the pods, right? So let's change the IP address service type to node port type. So how would you do that? You can do a kubectl edit on any of the running resource. So what am I editing? Kubectl edit service. I would edit the deployment service and press enter. It will open the VI editor type thing for you. And here you see the type. So let's delete this and say node port. So as soon as you save this, you would see a difference. Let's go ahead and do get service. Here it was only port number 80 and this. Now you see a mapping this. So now you're saying on the node, if the packet comes on 32572, then it is going to this particular service and service knows which port the packet has to go. So what you did, you created a node port. So the port number is 32572. Whenever the packet comes on the node, it would go to this and then it would lead to this. So if I have opened this port number outside, I should be able to reach. So let me pick the IP address of my droplet. :32572, if I'm not wrong. and welcome to Nginx. So what I'm doing on that particular node, on this particular port number, if I'm trying to reach, it is routing my packet to the service, and service is routing my packet to the Nginx endpoint. So this is how I am able to reach. So now the question could be, Mamta, now we have a single node. When we have a multiple node, what would happen? When we have a multi-node as well, on every node 32572 is opened for this particular service. Wherever the packet routes, it would, any of the nodes receives the packet on 32572, it would route it to the specific service. So whenever such type of node port mapping and all those things are happening, there would be entries maintained by the kube proxy on the Kubernetes cluster level so that the packet routing happens properly. So this is the node port type of service. Hope this is clear. The cluster IP is only accessible within the cluster. Node port is accessible outside the cluster, but only on a specific node on the cluster. If I just give the IP address of the node, I would not be able to reach. It will fail. It will not say welcome to Nginx, right? So if I would go on a particular port number, it understands that this particular port is mapped to a service. And that's how you know with this particular entry you understand. This particular node on the ports are mapped to this service, and service again has that endpoint list over here, and that routes us to the particular pod which is actually serving Nginx. So this is how it is for the node port. Let's go to the next one, the load balancer. Load balancer was once work on the cloud providers because we have a load balancer as a service, right? So you would have a cluster, you would have a set of pods formed from the deployment which are running. You create a service, but you say kind load balancer now. So when you say kind load balancer, literally a load balancer on the cloud provider gets pinned up. So now when we say it would be a load balancer getting created on the DigitalOcean load balancer, which is getting created. And now when the user tries to reach, load balancer receives the traffic. Load balancer understands that this is the service which has got created, and then it routes to the pod. So let's go back and check if we want to change this particular service to load balancer now. So I can do that. It's the same node port type of service. I'm just deleting, not deleting, I'm editing rather. And I would say load balancer. So with this, what would happen? As soon as you save, it will try creating a load balancer. You see there was none. Now there is a pending state. It has gone to the DigitalOcean load balancer level in the networking. It is trying to spin up a load balancer. Let's put a watch on this so that when we get the IP address, it would spin up. And let's go to our DigitalOcean networking thing console and see the load balancer. If you see, there is a load balancer getting spin up, and this would have a static IP address. When I reach that IP address, it would take me to the service, and service would again take me to the pods. So this is how we do. So let's wait for this load balancer to spin up and have an IP address so that we can reach the Nginx pod using that load balancer's IP address. So it would take some time because it is spinning up this. So parallelly, I'm showing the demo. In case you have any questions for 3 of the types of load balancer type, cluster IP type, and node port type, just post in your questions now so that I can address it parallelly the time the IP of the load balancer is coming up. So it would take a while for the spin up. So it's all good, no questions yet. And why we need this service is important because the IP address of the pods are not static, they are dynamic. We are creating a static endpoint for them by creating a service. And depending on the type of exposure you want to give, the type of connectivity you want to give, we are creating the type of service. I want to expose it only inside the container, cluster, it is cluster IP. If I am in a dev environment and I don't want to create a load balancer because load balancer will obviously cost me, I can do a node port. If I'm in a production environment where I'm exposing to the outside world, giving my IP addresses to the user, I have a DNS name for the mapping, I can have the DNS name mapped to the IP address of the load balancer. What about changing the port number 32572? So here earlier you could specify the request any specific port number, but now in the latest releases of Kubernetes, there is a range from 32,000. It automatically assigns a port number. You can't choose a port number now. Okay, so now if you see, there is a load balancer's IP address, and this is the IP address. So let's go and check whether our service is up and running on that load balancer's IP address. Yes. So now with this, what has happened? My packet has actually come. So let's draw that picture again, how it comes. So packet comes to this, the load balancer. From the load balancer, it has to come to the node, right? So it will come to node's IP address. What was node's IP address? Let's pick node's IP address. Sorry, it got clicked again. This is the IP address of the node. So it would come to node at 32572. And then it would come to the service at port number 80. And again, it would go to the pod's IP address, which I'm not going to look, and it will go to the containers port. So this would be the flow at this point in time. We first created this set. With this, I was only accessible inside the cluster. Then we went one step ahead. We created the node port one. In this, I had the port number, but on a node's IP address. And later, I give it a static load balancer's IP address so that I can provide that to the user. So if you see, it is like an hierarchical. When you are creating cluster IP, you just get a service cluster IP. When you are creating node port type, you are getting cluster IP address for the service, plus you are getting a node port. Just imagine it like a droplet. If you have an internal IP address, you can live with only internal IP address. But if you have an external IP address, you still have an internal IP address also, right? So cluster IP is like an internal IP address. Your node port IP is like an external connectivity, right? You are giving an external connectivity on a specific port. And with a load balancer, you have a load balancer created. You can reach there, you can attach a DNS name to that. With this, you can't give a DNS name because this is a node on the cluster, right? You can have several nodes in the cluster. So you would not attach the DNS name to this. Rather, you will give the DNS mapping to this so that if like, for example, I want to browse DigitalOcean.com, DigitalOcean.com will resort to this. It will take me to this, and then it would take to the service IP address, which is actually take me to the pod and the container port. So this is how the load balancer type works. So these are few of the types. Just imagine now I created an Nginx deployment in which I have created a load balancer type. I have a different Nginx pod also, right? In which I had the cluster IP. If I want to expose it outside, I would do a node port mapping for that. Let me just edit that for you and show that each time when we are doing, you would get a different IP addresses like port numbers mapped on the cluster. So I would do that as a node port and save it. You will see that this also gets a port number. So this one got 31326 and no, sorry, 31982 is the one. And if I make it as a load balancer, it would have a different load balancer created. You're not sharing the load balancer of Nginx deployment with Nginx pod. So let me make it as a load balancer and show you the output. So here it would have its own load balancer's IP address. So like this, if I have hundreds of services running, I want to expose hundreds of services, I would not go ahead and create hundreds of load balancers, right? It would be literally difficult to maintain it. So that is where the need of Nginx controller comes into picture. So let's see that. So here we would not wait for this because it will take a while to spin up the load balancer. We will put a wait and we'll go. So because every service which is getting exposed, if I don't want to do a node port, which obviously will not do in the production, I can't go ahead and keep creating a load balancer. Then I'm getting charged for the load balancer as well, right? So what we would do, we would create another uh, pod which would actually run a Nginx controller. So what exactly it is, like our load balancers are layer 4 load balancers. They do the routing on the network layer, but we can also create layer 7 load balancers using Nginx controller or HA proxy type of service so that it is intelligent enough to route on the URL based. So you can do a simple host based routing, URL based routing, path based routing, a lot of things can be done. So in that Nginx, Ingress one, you have two resources. One is the Ingress resource, which will have all the rules, and one is the Nginx controller altogether. And Nginx controller is the one which is responsible for reading the rules and then processing the data accordingly. So let's see how it happens. So when your traffic, you would create a Nginx controller running inside your cluster, which is like just a HA proxy or a Nginx controller running over there, which is a pod actually. And your packet, whichever is coming, is actually going to the pod. It is reading the rules which are there in the Ingress resource, and depending on the rules, it is routing. So let's see how it happens. I'll come back to this picture once I show you the demo over here. So I have already created Nginx controller because it takes a while to create. I'll do just get all and I'll show you the Nginx controller running. So this is the Nginx controller. I'll just describe and show you which image it has taken. Get will not help, so I'll do a describe. So this is the Nginx controller and you have the image. It has come up with the Nginx controller image. So what's the work of this? It will receive the packets, it will check the rules, and then it will route the packets accordingly. Okay, and if none of the rules matches, then it will route to your default backend. Here if you see, there is a default backend as well. So this pod is up and running. It's like a single point entry for any type of packets coming at this point in time. So I have an Nginx resource as well. So here I have written a rule like this. If someone is trying to open blog.mamtajhat-dev.in, then it should write to this particular service on this particular port number, and service obviously knows where's the pod, it will route it. In case I have multiple, I can just copy paste this complete block. Like for example, I don't have two domain names, so this would not work actually, but I would show you how I would do. So I have two different, like for example, if this is com, I have two different websites running, okay, and two different pods are serving that particular website. I can have entries like this. You can even have different paths defined, like .com/docs, .com/tutorials. You can serve tutorials from one set of pods, serve docs from one set of pods. You can even do that. So let's save this. I'll just delete these lines because I don't have that. Okay, so let's create this. Let me check whether kubectl get ingress is created. Okay, so Ingress is created. Ingress says that whenever the host is this, the address should be this. Why I have created this already? Because this would actually, I have to map to the DNS name. I had to make the DNS entry so that all the DNS servers in the world gets updated, and when we try to open it, it would open the web page, right? So that's the reason I have pre-created and kept it. Now let's create the pod and the service. I have the Ingress controller running, I have the Ingress running, but I don't have the pod running. So pod and service are not there. So I'll show you this particular file. So I am saying the pod over here, it's of a cluster IP type. Port number for this particular service is 80, target port is 8080, and it is serving for this particular pod type, right? So pod name is over here. The label is specified over here. So the label and this selector should match so that the service and pod mapping is done. And container is listening on 8080. So the target port for the service has to be 8080. This is done. So let's create this. Let's use the kubectl create command -f with hello first.yaml and create the service and this. So let's list the service. Yes, service is created. Let's list the pods as well. Is it in running condition? It's creating. Let's do a watch on that. Okay, it's up and running. So now what would happen? I mentioned that Ingress is the single point of contact to receive the packets. When I am trying to reach the Ingress controller, it would route my packet to the proper path by reading the Ingress rules. So let me get the IP address of the Ingress controller. So this is my Ingress controller's IP address. If my packet reaches the Ingress controller, how it would happen? Let's see that. My packet which reached the Ingress controller, it will go and verify the Ingress rule. So in the rule, what is mentioned, if someone is trying to open blog.mamta-dev.in, you route it to the service. And which service? This service. Service name is this. So it will route it to this particular service IP on port number 80. And this service understands that I am for this particular deployment, and it will route to these containers, right? So it will go to the endpoints of the pods. So this is way it would route, because it would take time for the entries to be created in the DNS and all. I have pre-created the controller. So it is going to the default backend over here because I'm just giving the IP address. So now what you have to give? You have to give blog.this. So with this, I am able to reach. In case I had a .com, I would have reached hello from the second deployment, right? In case nothing, I am not specifying anything, then I am giving the IP address. It is taking me to the default backend because it doesn't understand. I'm just reaching the Ingress controller. None of the rules are matching. It takes me to the default backend. If the rule is matching, it is taking me to the match service. Service is routing to the pod and it's showing me the web page. So this is how it happens. So when you have multiple services running and exposed outside, you can create an Ingress controller rather than creating thousands of load balancers to be exposed outside the world. So this is how we do it. And just depicting in this picture, the traffic came to the load balancer, it came to the Ingress controller. Ingress controller matched the rule. So it matched one rule, it goes to the service. If it matches the other rule, it goes to this service. If it doesn't match any rule, it goes to other, where it is serving the page 404 or the default one, right? So this you can create. When do we do this? Ingress is very powerful for exposing service. You can use to expose multiple service with the same IP address. My IP address remains the same. You can define the paths with that, right? You can do that. And this has the intelligence of path-based routing, URL-based routing, all those things over there. So it is a layer 7 protocol-based router. So this is what I had for today's session. It's .7. If you have any questions, please feel free to post your questions now.